Hi, for today's YouTube video, I want to discuss about two security features that are most widely used in all corporate sectors. If you go to any IT office or any corporate office or any medical lab, they will secure the room using Face ID or fingerprint scanner, right? So these are the most widely used security features, security operations. Instead of using a pin code or a password, the companies, corporate companies or IT companies, they prefer to use fingerprint scanning or face ID detection or both. So because the combination of these two, fingerprint scanning and face ID recognition, is a kind of high secured scenario that you can actually secure any room or any corporate location before entering into any lab or any restricted area. So I want to explain how it will happen in the back end. I want to explain the technical things that are there behind these security features like fingerprint scanning and face ID. I can explain you using a simple Python program. For example, you see, we can implement it using many programs. So the best way used to implement both the fingerprint and face ID detection is using C++ language, because C++ is the best language which can actually talk to the hardware directly with its native implementations, native libraries. If you take Java, Python, these are the Java is a compiled programming language and Python also interpreted, not very much efficient. So C++ program is one of the best programming model that can actually we can actually use it for embedded programming. You can you can program embedded systems, and you can actually implement best and performance effective solutions. So just for understanding, I am going to explain this using a Python. So Python is one of the best academy programming language. We all know that, right? It is having a rich set of predefined and pre-trained libraries. So you can see here we are going to import CV2 library, okay, which is used for reading, web camera, and face recognition library is there. Okay, it is actually written a predefined library which is used to read the face from an image. So you can see first what we are doing, we are going to read a particular image, person.jpg. We are reading the known image, and then from the image we need to convert that image into vector. Okay, so we are using known encoding equal to face recognition dot face encoding known image, and that image will be converted into some vector. And after that we are going to have a while loop, infinite loop, and we're going to read a face from the camera, live camera. You can see ret comma frame equal to, we're going to read frames from the video camera of a particular person. Here we need to observe one thing. Already a photo copy of a particular person is already stored in the database. His face image is already stored. So now whatever we are reading through live camera, we need to compare this face ID with the stored face ID of a person. Then only we will make sure, if it matches exactly, then we will give a confirmation that the face is authenticated, face ID is matched, like that. Okay, so now you see, once we are reading a live face from the camera here, and we are getting again face recognition encodings. Okay, face encodings. So now we need to compare the stored encodings and the encodings that are read from the webcam. We're comparing both the things. You can see the known encoding, okay, and previous encoding. So known encoding is the you can see known encoding is already stored db face id, and encoding here there is a you can see there is a we are reading encoding here. See, the encoding is from the live webcam. Okay, and we're comparing both the things. If the match is occurred, then we are saying the person is a known person, otherwise the person is unknown. Okay, yeah, so you can see that's how the logic works here, underlining the technical logic implementation. Okay, and based on that we will confirm whether the face is identified or not. So see, the security feature is we can implement the security feature with the low cost also. It's not a big deal, right? So the simple program, we can actually write it, and we can actually write this program into embedded system so that the embedded system works perfectly. The underlying logic is very simple, and device cost is also very low. You can use you can also use Raspberry Pi if you want to build a low quality proof of concept project. You can do that. So face ID recognition is very important. You can use existing open source codes, and you can do that. Why I'm telling is, you know, when you look at the corporate offices, and people think corporate offices will spend millions of dollars to implement these security features, both face ID recognition and fingerprint scanner, but that is not true. You can actually build these solutions using a low cost features as well. So even that is why the government should come forward to take this opportunity, to take these features into the governance of the nation. So it would be so helpful. You can actually incorporate these security features for all governing offices, important governing offices in India. You can do that. Okay, these features are very important. So what I'm trying to tell, I mean, these are not very high cost features to implement. We can implement it with reasonable cost. Okay, I mean, what I'm saying is, you can actually include these security in main governance departments or organizations of government of India, so that you can avoid the corruption, and you can avoid the misuse of the governing services. That is what I'm trying to tell here, and I'm going to explain the fingerprint scenario here. Just go ahead here. I'm going to tell what is the fingerprint, how it happens. So okay, let me explain you. So this is all about the face detection and how fingerprint scanner. You see the fingerprint workflows. Generally what happens, the fingerprint scanner will be there, and it will capture the fingerprint image, and after that it will enhance the image, extract the these, and it has to extract the image to get the proper patterns, and after that create a fingerprint template, and it will store the fingerprint template. Next time when you scan the same fingerprint, it will actually compare the existing stored fingerprint details with the live fingerprint scanner. So as I told you, C++ is C or C++. These programmings are used. Most commercial fingerprint SDKs are written in C++ because they are very fast and they can directly interact with the hardware. They are very fast. C and C++ are very fast. For simplicity, I'm going to explain this using Python only. Again, you see here what we are doing. We are actually reading a fingerprint image. I'll explain how this image will be captured. So here we are talking about the stored image. Already there is a fingerprint image was formed, and we are going to use that for comparing. But how that fingerprint image initially will be taken, I will explain that also. Okay, for now you can see here image cb2.amdate, and after that we have to from the image we need to gather some grayscale color patterns. Okay, and we have to detect the key points from the fingerprint image. You can see from the image we are going to detect key points and descriptors. There are some patterns. What are the patterns? Valleys and what we call, I'll explain. See here there are ridges. So in this image you can see the dark spotted things are ridges, and the valleys also there. These are the kind of patterns. So when you look at your finger, right, you will have ridges and valleys. So they are the kind of patterns. So we need to get the key points, and after that from the key points we need to get the actual pattern, how the fingerprint was formed. Basically these points are distinctive points in the fingerprint that can later be compared between two images. So what we are doing, we need to find out different patterns. So the image will have a different patterns, pixels, right? So it will read all those things. So we are using inbuilt CV2 library, draw key points from the image, and then we are getting all the key points into output variable. You can see here, and from the output variable we're going to see the image. It will show us the pattern image. So now you see how the two images are going to compare. We're going to get both the description and descriptors and key points for both the images, and we are applying a matcher, cb2.bf matcher, and this matcher will confirm whether both the images are having same fingerprint patterns or not. If both are matched, then will confirm whether the match is correct or not. So what I am trying to tell, you can see the image here in the security for fingerprint scanning, face ID detection using cameras. They are very good solutions for implementing the security at corporate offices or government offices or restricted offices. You can take anything. And other thing is, you look at the images, how the pattern when you put a finger on fingerprint scanner, what happens, I'll explain. You can see it takes the multiple images. It reads the patterns of your finger, it reads the ridges and valleys. Okay, it actually scans the ridges and valleys and takes that photo pattern, and finally it will refine that pattern to ultimate feature, ultimate by extracting the multiple features, it makes it refined pattern image, and it will store that these points, it will store that whole image like this in a vectors, you can see. And after that, whenever you scan your finger using a fingerprint scanner, what it will do, it will compare the existing data with your fingerprint scanner, with your scanned fingerprint. So the thing is here, what I'm trying to tell is you can implement both the security features for many government offices as well, because these features will give you a lot of security to the government offices, restricted areas, highly sensitive areas, so that we can avoid the corruption and other illegal access and illegal usage in governing offices. So not only in corporate companies or corporate million-dollar companies, you can also use even in average normal business companies, or mini startup companies, or if you are doing a small business, even in unorganized sector also you can use it with a little budget. It's not a great deal. So that is what I'm trying to explain. So I hope this full video will be useful for you. Thank you.